Today's exciting geometry lesson is on angle basics and angle pairs. So what is an angle? An angle is formed by two rays which have the same endpoint. So here we have ray AB and ray AC. And we can name angles in three different ways. We can name them by their vertex, so angle A. We can name them with 3 points, one being the vertex. The vertex is always in the middle, so we have BAC or CAB. Or if there's a numeral in the angle, we can name it by the angle. So in this case, angle 1. The most exact ways are to use 3 letters. That way we know specifically what angle is being described. The vertex is the end point of the angle. In this case, it's A. An acute angle is an angle less than 90 degrees. A right angle is an angle which is exactly 90 degrees. An obtuse angle is an angle which is greater than 90 but less than 180. A straight angle is an angle which is exactly 180 degrees. And the measure tells us how large an angle is. Important definitions, so if you need to pause the video and write these down, that is a great idea. Now we have some more definitions when we're talking about angles. Some important angle pairs to note is adjacent angles. Adjacent angles are two coplanar, meaning on the same plane, angles with a common side and vertex but no common interior points. You'll notice here angles 1 and 2 are adjacent angles. They share a side but they don't overlap. Vertical angles are two angles whose sides are opposite rays. So you'll notice it makes like an X, and 1 and 2 are vertical angles. Complementary angles are two angles whose measures have the sum of 90. These can be adjacent angles, but they don't have to be. Supplementary angles are two angles whose measures have the sum of 180 degrees or form a straight line, but they don't have to be adjacent angles. They can be. And a linear pair is a pair of adjacent angles whose non-common sides are opposite rays. So angle 1 and angle 2 are a good example of a linear pair. Linear pairs have to have adjacent angles. Again, make sure you have these definitions recorded. So geometry is all about proving things. And there are certain things we can prove and certain things we can't assume. And so these first section is things that we can assume. I can assume angles are adjacent. I can assume they're linear pairs. I can assume that angles are straight. They're also supplementary. And I can assume angles are vertical angles. I don't need somebody to tell me that. I can assume it by a drawing or on a diagram. There are things I can't assume based on its visual appearance. That would be acute angles, or complementary angles, or obtuse angles, or right angles. Those 4 things I can't assume unless they are labeled or I have specific information that tells me that those are the types of angles they are. So look at these 4 diagrams. I want you to pause the video and identify the angle or angles shown. So let's look at example 1. We have 2 angles that form a straight line, which means it's going to be a supplementary angle, it's going to be a linear pair, and it's also going to be adjacent because they share one side. If we go to number 2, 47 and 43 add to 90, so we have complementary angles. They're not touching, so they're not adjacent. 1 and 2, now this one's a tough one because it doesn't really look like anything. But remember, we talked about vertical angles having opposite rays or forming an X. So in this case, this is an example of vertical angles. And last but not least, 68 and 112 add up to 180. So we have supplementary angles. This one is not a linear pair like the first one because they're not adjacent angles. Linear pairs have to be adjacent. Now finally, we have a few postulates, so make sure you switch colored sheets and write down these postulates. The first one is the angle addition postulate, and this is very similar to our segment addition postulate. It says if point B is in the interior of angle AOC, then the measure of AOB plus the measure of BOC equals the measure of AOC. And I know that's kind of confusing, so let's look at this diagram. I use different letters in the diagram, but it still gives us the same idea. So what it says is, if I have the angle QRS, that's my first angle, my biggest angle, and I break it into two smaller angles, so I have QRT and TRS, these two pieces of the angle add up to the whole big angle. So for example, 40 and 83 means the whole angle is 123. Just like the segmentation postulate, if I take an angle, break it into two pieces, those two pieces should still add up to my original angle. And the last postulate is the linear pair postulate. And you may have assumed this based on the information, but remember, can't assume things. So the linear pair postulate says that if two angles form a linear pair, then they are supplementary. And we saw that in those diagrams. When two angles form a linear pair, that means they're a straight angle. And two angles that add up to 180 are supplementary. So linear pair postulate just means that if they're a linear pair, then they're also supplementary. Very important postulate, so make sure you know that one. Well, that's it. So we'll see you in class. We're going to do lots of practice with angles. Bring all your questions and your definitions and notes to class. Have a wonderful evening.